What's up, guys, and welcome back to another live stream for the weekly contest of Code 360. Let me check if the stream is working properly, and then we'll register and then solve all four problems right over here. Okay, let me see it first. Okay, so I am live. Let's register for this contest and solve first question because we are already late. Yeah. So your camera is on, and sorry for the backgrounds. Actually, I'm inside my hostel, so I can't do anything. This is what my background is. Okay, starting with our first problem, and it says that a gaming platform, each username is assigned a score based on its characters. So the score of a username is calculated as the sum of position of its letter in the English alphabet. Okay. For example, A has position 1, B has position 2, C has position D. Okay, jet 26. Both uppercase and lowercase have the same value. Your task is to rank the username based on their scores in descending order. Okay. Your task is to rank the usernames based on their scores in descending order. If two usernames have the same score, rank them lexicographically. Okay, nice question. So let us first try to dry run this question and then we'll solve it. So let us take this example. I'm unable to copy here, so let us make a multi-line comment. After that, I'll write Alice and then Bob and then Zara and then Tom. So these are the four given usernames. Now, your task is to rank the username based on score, and a score is the position. So for Alice, if the position is 1 and L12, so sum of L12 plus I9 plus C3 plus E5. So the total sum is 113 and then 22 and then 28. So this is 28. This is Bob, which is Bob has 2 plus O 20 and B 20. So it is 24. For Zara, it's 26 plus 1 plus R18 plus A. That is 1. So the total summation is 46. For the Tom, it's T20. I think this is 15. So for 15, it's 19. O for 15 plus M for M13. Okay, so the total sum is 538 and 48. Yeah. So if we try to arrange this in decreasing order, then the first word will come as Tom, and the second one will come as Zara. The third one is Alice, and the fourth one is Bob. So this is the final answer. Is it correct? Yeah, 100% correct. So for solving this question, we have to make the case lower. Yeah, we have to make the case lower so that we can store the values in hashing. And for that, we'll first make we'll first make the usernames as lowercase. So what we'll do, we'll try to mm, we can do it using priority queue as well, but I'll try to do it in a simpler way. And that is let's use priority queue. So import heap queue, because at the end we have to sort the array. So let's use priority queue. So PQ is empty right now. And what we are going to do is for each username, in usernames, first of all, we'll lowercase the username as to lower. Is it a function? Let me check. To lower in Python. Is it a function or not? Let me check. Python doesn't have the function, but s dot lower. Okay. So the username, uh, lower name, we can say lower name is username dot lower. Now we'll calculate value for each of the usernames. So for that, we'll check if we'll calculate a score. So our initial score will be 0, and while we'll take a iterator that is starts with 0 and I is less than length of lower name. Okay. Or simply we can iterate over the username. So for ch in lower name, what we'll do, we'll increment the score with ordinate value of ch minus ord value of a. So it will give us a minus a, that is equal to 0 plus 1. Okay, plus 1. So in this way, we are able to get the value of OID ch minus 1 plus 1. And at the end, what we do, we'll push heap q dot heap push pq comma uh, score comma uh, lower name, or we can say username. Okay. And at the end, what we'll do, we'll try to extract our result, and that is a list of strings. So sorry, for each element inside the priority queue, or we can say while PQ. So what we'll do is we'll try to destructure it. So score that we are not gonna use since we want it in decreasing order. So what we have to do is we have to score it -1 so that the top score will be minimum. Yeah. So for this and username equals to heap q dot heap pop of pq, and we'll try to push it inside the result. So it's username, and at the end we'll return the result. Let us run this and see if it's working fine. None type object is not iterable. What does it mean? For name and result. Where did I use it? For name and result. For name and result. Uh, none type is not iterable. Why PQ? While PQ. If Q correct, yeah. Let me check. N should be 1. Yum, 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 yum. That's totally fine. If n equals to 1, then return user names. Nope. It is a base case, I know, but it's saying line number 21, return result. Uh, yeah, it is working 100% fine because we were able to do it in n log n plus this. Yeah, so this is the first question, and let us go toward the second question, and which is also an easy question, but let us see how we can solve it. So a delivery vehicle must travel through several stops along a fixed route. The distances between consecutive stops are given. The delivery vehicle must travel through several steps along a fixed route. Okay. So the distance between consecutive stops are given. A vehicle has a fuel tank with capacity F units. The vehicle consumes 1 unit of fuel per unit distance. Okay. So the vehicle start with a full tank and there are no refueling points between stops. So your task is to determine whether the vehicle can complete each assignment between stops without running out of fuel. So the vehicle starts at a full tank and there are no refueling points between stops. Your task is to determine whether vehicle can complete each segment between stops without running out of fuel. Your task is to determine whether the vehicle can complete each segment. Okay. So let us try to dry run this question because without dry running it, I cannot understand. So yeah, we are getting fuel capacity equals to 10 here, and the stations given as 3, 5, 8, and 6. And the output is yes. Why output is yes? Full fuel capacity is 10. Segment distances are this. Each segment is less than 10. So vehicle can travel between all stops. Nice, 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 nice. So your task will depend whether the vehicle can complete each segment without stopping. Stops. Okay. So this is a very easy question. I can do it in a second, I guess. So what we have to do is we have to return a list, return all all stops are less than equals to F for stops in census. Yeah. Mm, okay. We don't have to return um, true or false. We have to return yes if rest else no. Eh, it is working. It was a very easy question. Let us go towards the third question. And before that, I want to check that how many of you are watching my video. Okay, nice. So there's only one watching, and I know this contest is not that much famous. That anyway, I used to do streaming of this. Let us go to the third question. The third question says maximum card score. There are several cards arranged in a row, and each card has an associated number of points. So given the integer array cards points, if one step you can take one card from either at the beginning or at the end, you must take exactly k cards. The score is some okay, okay, okay. This is a sliding window question, and I definitely uh I had solved this question. I think 3 4 months back. I just got hit this question, and yeah, we'll solve it in a minute. Okay. So I'll first dry run this question and then we'll solve it. So for the input, for the k is equals to 3, and the input is 1, 2, 3, 4, 5, 6, 1. So what we can do here is we have to take three elements, either from the left, either from the right, or from the combination of both, and we have to maximize the score. So the possible values are, uh, if we are taking all the values from the right, then the possible sum of the score is 1, 1 plus 2 plus 3. If we are taking all the values from the right, then the sum is 6. Now, if we are taking all values from right, the sum is this. If we are taking all values from left, then the sum is 5 plus 6 plus 1. So the answer is 12. And if we are taking mixture of both the values, then the combination which we can take is one value from the left and two values from the right. So this will give us 8 as our answer. Now two values from the left, which is 1 plus 2, and one value from the right, which gives us 4. So the maximum sum is max of 8 comma 4 comma 6 comma 12, and that is 12. So the answer is 12. So I think you got to know how this algorithm is working. We are just basically doing sliding window, and it is a variation of sliding window with a window size k. So the approach should be, I'll write the approach here. What I'm thinking right now, approach is to take sum of, to take initial sum from left side of k elements. Okay. Now the second step is subtract one element from uh, left, plus add one element from right. In this way, the window size of k is always maintained. So k window size is always maintained in this way. And the third step is maximize at each step. So this is the main approach that I'm gonna code here. So let us take the initial sum, which I'll take as left sum because we are taking sum of left values, and that will be the sum of card points up to k. Up to k, it means uh, I can use array slicing here. So left sum will be this, and now what I'll do is I'll try to subtract one value from the left and add one value from the right. So what I'll do is I'll start with for uh, what I can do is I'll take an iterator I, which is equals to k minus 1. So we are at the k minus 1th index. For example, if I am here at the 3, so the value of k is 3, so the 3 will be here. And the invalid case for this is if the base case that I can guess is if base case, if k is greater than, if k is greater than length of card points, then return, then what you have to return? Return. But since the constraint is given that the k value will be less than, so that's totally fine. So we don't need this base case right now because it is given in the constraint. So we are taking ith value as I, and jth values as what, the last value, that is n minus 1. So length of card points minus 1. Okay, length of card points minus 1. So jth value. Now what I'll do is, while I is greater than equals to 0, okay, I is greater than equals to 0, what I'll do is I'll take a maximum here, max sum, or I can say max sum equals to currently the max sum is left sum, and I'll try to maximize the max sum. So the current sum will be left sum, uh, left sum minus card points of I plus card points of j. This will be our current sum, and our max sum will be maximum of max sum comma current sum. So this will be our sum, and at the end we'll decrease the value of I by 1, and we'll decrease increase we'll also decrease the value of j by 1. In this way we are able to maximize the sum and at the end return max sum. So let us try to run this question. It was a medium level question, but yeah. So currently our output is not coming as expected. Why so? Because the output is 10 right now. Why? Max sum is equals to max sum comma current sum. Okay. So we are okay. We have to update the left sum, no? Do we need to update the left sum? Hmm. Yeah, we have to update the left sum. So what we'll do is control copy, control B, minus equals to, and then left sum equals to this. I think now it will work. No. First we are subtracting the left sum. Copy, paste, and then delete it. And then plus equals to j. That's the mistake I was doing. Hmm. Current sum is not defined because we are using left sum here. Now let us run. And yeah, it is working 100%. So yeah, this was the third question for this contest. Let us go towards the next question. We are very quick, while solving this question. So let us discuss the time complexity. For finding the sum, this is big O of k. I'll write here big O of k. And this will also take big O of k. Okay, so the final term complexity is big O of k or big O of n if n is equals to k. If n equals to k. Yeah, so let us go for the next problem. The next problem says maximal rectangle. Okay. So it is a hard question, hard tagged question. I don't know if it's actually hard or not. You are given a row into column binary matrix filled with zeros and one. Your task is to find the largest rectangle containing only ones and return its area. Nice. So just by seeing the problem, it's similar to connected island that I used to solve in graph problems, and it is a DFS or BFS problem. It's a graph traversal problem uh, that I can see or think of. So we also have to find area here of the largest rectangle. Okay. Hmm, very good problem. Here the largest rectangle is 1 1 1 1 1. Here the largest rectangle is this. Okay, the largest rectangle here is this as well, this as well. So we have to finally maximize the rectangle. The largest rectangle of ones here has a height of 2 and a width of 3, located with its top left corner at 2 comma 2, and its area is 2 into 3. So it's at 2 comma 2. It's 2, but it's 1. Okay. Nice. So for this, we have to expand what I'm think of is we have to expand. It is not a graph question, that I'm sure. I was a little bit confused because I was thinking that this can also be an island. This is a maximum island. But here, what we have to do is for each point, we have to, expand the output, expand the area. So for that, what we can do is, the case that I'm thinking of is, let us dive in this question and then we'll try to solve it. So if I am taking this area 1010, so if I write here 1010, so for this one, I'll check if all the neighbors means bottom bottom neighbor, uh, right neighbor, and right diagonal, right lower diagonal. So these are the three neighbors for each index. So for index I, the neighbors are I plus 1, j plus 1, and the combination of I plus 1 comma j plus 1. Okay. This is this can be solved using recursion as well. Okay, nice. I got a mail just a minute. Yeah, so that is for today. We are, quitting this contest here. I'll be able to solve this problem, but I have an urgent work. So bye bye. See you in the next contest.